Hello everyone. In this video, I'm going to be talking about decorators in Python. A decorator is a unique type of class or function that allows us to extend the behavior of another class or function without causing any permanent changes to them. If you are already versed in other programming languages, then you may already recognize this concept by a more general term, a wrapper function or class. But the word decorator is more than just another name for an already existing term in Python. Decorators are best described as syntactic sugar, which literally means to make things easier to read or express. To demonstrate the syntactic sugar in action, let's review a code example from one of my previous videos, Python functions or objects. This is just a very general basic form of what a wrapper function can look like. It's just another function that takes in another function as an argument and then calls that function itself. And there's usually other things going on inside this wrapper function as well, such as print or logging statements, or maybe even some extra data manipulation. And Python has a more Pythonic version of this example, and that would be by using a nested function like this. So up here we have a function called wrapperfunc, and inside of it we have a nested function defined called internal function. An internal function is what's doing all the work. It's printing out some messages as well as executing the function that gets passed into wrapper function. And at the end of wrapper function, we return the function name of the internal function. And then here we've got our regular function that we're going to call called print message, and it just prints out this one message here. So if we wanted to wrap this function, we would call the wrapper function here, pass in the function name of print message, and then we added an extra set of parentheses here, because when we return the function name here, this extra set of parentheses will be attached to that function name so that it gets executed immediately. So when I run it, we've got our messages here and here that gets printed by the internal function inside our wrapper function, and then in the middle we see the message from the function that we were wrapping with the wrapper function. But as you can imagine, both of these examples are pretty wordy and would make the code hard to read. But if you were to ask a Python developer to choose between the two examples, they'd most likely choose this one. And this is where decorators come in, because it is this exact example here that decorators are syntactic sugar for. They allow us to accomplish the same effect here without having to use a wordy code execution every time. So here's our first true decorator example. So we still have a function here with a nested function inside of it. That is the basic signature of a decorator function. The outer function only has one parameter, and that is the name of the function that is going to be decorated. The inner function typically does have some parameters as well, but I'll demonstrate that in the next example. For this one, I just left it blank. And inside the inner function, which is the actual wrapper function, we have our code here where we're printing messages, maybe logging some stuff or doing some computational stuff, and then we execute the actual function here. And then at the bottom of our outer function, we return the function name of our inner function. And then to decorate a function with this decorator, we start with an @ symbol here, followed by the function name of the decorator function, just like this. And we would do that over every function definition that we would want to decorate. And so now, all we ever have to do is when we want to call the function, we just call the function like normal, as you can see here. So when I run this, it behaves exactly the same way as our previous example. It prints out the messages from our inner function here. Then it executes the function that we wrapped, and we see the message right here. So it's exactly the same output as our previous example, but the code looks much nicer, it's easier to read, and we don't have to write this every single time that we want to have this effect. We can just call the function name like normal. But this example uses a function with no parameters. If we want to decorate functions that have parameters, we need to code our decorators to handle that. Fortunately, that's a very easy thing to do, and there's a one-size-fits-all way to do it. So in this example here, we have our decorator function at the top that's coded to handle arguments, and then down here we have two different functions, one that takes no arguments, and another one that takes two arguments that are both decorated by this decorator. So the one-size-fits-all way to code a decorator to handle arguments is that we put these two parameters inside the inner function. And these two parameters are actually used in a lot of places in Python. Usually it's stuff under the hood, things behind the scenes that we don't normally see happen in Python, but Python does do stuff like this. But we can use them specifically ourselves as well, such as this decorator function. So what this one here represents, args, any arguments that we pass in where we just pass in the value itself. What kwargs represents are the keyword arguments, and those are the ones where we specify the parameter followed by the value inside our function calls. And I have a couple examples of that down here. So in this one, args is going to be filled up with a and 17. But in this one, args will have B, but kw args will have a dictionary mapping showing count being mapped to 10. And I have some print statements so you can see that happening. Args will be the form of a tuple. kw args will be in the form of a map object like a dictionary that shows the mappings of the specific keywords we specified to the values we set them to. And then down here, we take the function name that's passed into the decorator function and we feed in any parameters that are contained in args or kw args in the wrapper function into our function call. And this works for any function. If the function doesn't take parameters and we don't feed any parameters into it, this will work because both of these variables will be empty. If we have functions that do take parameters and we feed in whatever combo of parameters or keyword parameters into the function, it will get fed into this and it will work just fine. I have two functions here that are completely different with parameters so that we can show that this decorator will work on both of them. So we call the first function here print message, which is basically the same as the previous examples. Don't mind these, that's just to add some blank lines in the output. And then I call repeat twice. The first time is just to pass in some values straight in. And the second time is to show you the difference between passing in a value and passing in a value directly into a parameter name so that we can see the differences in printouts here for both args and kw args. So when I execute this, the first one, there are no parameters, nothing gets passed in, so these are empty. And then it executes the actual function call, which is printing out the messages from the actual function. And then for our second set of output here is when we call this repeat function with a string, the letter A and a space, followed by the number 17. And since we just passed those values straight in, they all go into the args variable and kw args is empty. And then we show ourselves executing the function here, which is basically repeating this string 17 times. And then for this last bit of output, we call repeat again, but this time we pass in the string with a capital letter B followed by a space, and then we specify the parameter count and we set it equal to 10. So it prints out the args. We've got the letter B followed by a space, and then kw args has the parameter count that's set to 10. And then the B space string repeats itself 10 times. So that's how we would write a decorator to handle functions that contain arguments. Considerations also need to be made for functions that return data when being decorated. Fortunately, this is also a very simple thing to do. So in order for a decorator to handle return values, we simply need to have the nested function return that value. So in this example here, when I call my decorated function, I have it store the result inside a variable and then I return that variable. So that when we call this here, this will return the value of the function that was decorated into this variable here. So when I run this, we can still have our message printed out. We're not limited to the number of decorators that can be placed over a function. We can use as many decorators as necessary. However, we are not technically decorating a single function with multiple decorators. Instead, we are chaining them together. So in this example here, I have two decorators. They're both coded to handle arguments as well as return values. But on top of that, I've added print statements to show in what order that these decorator functions execute, as well as which functions they are actually decorating. And then down here, I have a single function that's being decorated by both decorators. So the way this works is that decorator function 1 is technically decorating decorator function 2, which is then decorating the actual repeat function. So when we call the repeat function, repeat first gets passed into decorator function 2, and then decorator function 2 gets passed into decorator function 1, but they get executed in the order that they are listed. So decorator function 1 will execute first, then decorator function 2 will be executed, followed by the actual repeat function. And in this situation, it's not technically decorator function 2 that's being passed into decorator function 1. It's actually the wrapper function inside of decorator function 2 that's being passed into decorator function 1, which will be shown when we print out the actual function name. And it's absolutely important that all decorator functions, when being chained together, handle any potential arguments as well as any potential return values, because that has to get passed all the way back up in order for it to get handled in the actual code. So when I run this, so we see the message for the first decorator. The first decorator was called first, and then it prints out the function name, which is decorator function 2 dot wrapper function. And then that function gets executed. So the message second decorator called gets printed out. Then we print out the function name that's being decorated by that decorator, which in this case is our repeat function. and we don't see anything get printed out by the repeat function because all it does is return a value. So then we see the second decorator ending, followed by the first decorator ending, and then finally, in the actual code down here, we print out the message that was generated by our repeat function. So that's how chaining multiple decorators together works. Decorator functions are capable of having extra parameters in addition to the required function parameter. In order to do this though, we need an extra layer of a nested function. So in this example here, I have an outer decorator function, an inner decorator function, and then our wrapper function. The inner decorator function is the true decorator function, but it's the outer decorator function that we use to decorate all of our functions with. And it's the outer decorator function that will also take in the extra parameters. So the parameter we have for our outer dec function is high priority. It's going to be a Boolean value that takes true or false. And what it does is it controls this little condition right here inside our wrapper function. And if it's true, it's going to add some extra output to the return result of the function we decorated. And down here, we just got our repeat message. It's going to repeat a message multiple times based on what we specified. And when we run this with the decorator parameter set to true, we're going to see a message that says high priority alert, followed by this little fancy underline thing. And then we're going to see this message repeated twice. And then this part here will slice off the last character in the ultimate return value, which at least in this case, we'll get rid of the new line. But if we don't have that new line, it might splice off a character. But for the sake of this example, it's going to do what it's intended to do, which is to get rid of that last new line character at the end of the string. So when I run this the first time, we see the high priority alert message and the little underline thing, followed by our actual message. But if I were to go and change this to false, and then run it again, we just get the repeated message. So that's how you would define decorator functions to have extra parameters on top of the required function name parameter. Now, so far, I've only been demonstrating the use of decorator functions, but as I mentioned in the beginning of the video, we can also have decorator classes. In this example here, I've created a class called Dec class. It has a class attribute called DecCount, and it has two magic methods. We have our standard init magic method, and we have the call magic method. The call method is what is required to make this class a decorator class. And for parameters, the init method just needs the function name, and we use that to store it into a self.func. You can call the variable whatever you want because it's the variable you manually call, but you do need to store it into a variable for the object. And then for the call method, in addition to self, we specify the args parameter as well as the kwargs parameter. And in here, we call the function, we pass in the args and the kwargs if any, and then as an extra bit here, I have the dec count get updated by 1. So it keeps track of how many times any function that it decorates has been called. And then it returns the results of the function, if any, as normal. And then I got two functions here that will be decorated by the decorator class. And then I have the results outputted down here. So when I run this, we got the output from the call here. It's printing out the function name that it's decorating. So decorating func1. It executes the function itself. In this case, func1 just prints out a test message. And then dec class will update its count for the number of functions that it's decorated so far by 1. And then we call func2. So the dec class will print out the message decorating func2, and then updates its decorated count. So that means that a total of 2 functions have been called that it decorates. And then we print out the output from that function because it only returns a value here. And we pass in 2 and 3. So 2 times 3 is 6. So it prints out the number 6. And that's how you would create a decorator class. As I also mentioned at the beginning of this video, we can decorate classes too. So let's take a look at how to do just that. Defining a decorator to decorate a class is actually no different from defining a decorator to decorate a function. The outer function takes in a single parameter, and in this case, I'm just calling it CLS for class. You could technically call that parameter whatever, but usually you would call it function or CLS or something to indicate what it's going to take in. And then the nested function wrapper just takes in args and kwargs. Inside the function, we actually create the object from the class we passed in inside of it, passing in the args and kwargs if there are any, and then we return that object from the nested function. And then down here, we would decorate the class the same as we would a function. And then I just create the object from the class like normal, and then I just print out the object's name. So you can see that it is in fact been created and stored in the variable p. So when I run this, so wrapping class pilot, and then it prints out the pilot's name, Crozo. We can also create decorator classes to decorate other classes. And much like decorator functions, their makeup is pretty much the same as a decorator class for a function. So in this case here, I've got another decorator counts. I've got another init function. It takes in a class instead of a function. We got the same call method with the same parameters. And here we just create the object using the class that we passed in here. We update our decorator count. We print out a message saying how many classes we've decorated. And then we return the object so that it gets stored into P. And then we print out p.name to prove that the decorated class built the object properly. And as you can see here, we're creating two pilot objects, one named Crozo, one named Ben. So when I run it, we get two messages saying that we've decorated the class pilot. It prints out the count to show how many times it's decorated a class. And then it prints out the pilot names, Crozo and Ben. So that's how you would decorate a class with a decorator class. And that's about it for decorators in Python. So I hope you've enjoyed this video and found it helpful, and if you did, then please hit the like button and leave a comment below to let me know what you think. And if you want to see more, head on over to Wayfair Coding Academy channel to check out my other content. And while you're there, subscribe to the channel to stay up to date on new stuff as it comes out. Thanks for watching, and I'll see you all next time.